CLO for this lesson is that students will be able to solve in writing for x using adding, subtracting, multiplying, and dividing, as well as the following language: transition words, and the vocabulary inverse, eliminate, isolate, and operation. So transition words is slightly different than the if-then sentences you've been working on. Then itself is a transition word. But transition words in general are words that we use to go from one thought to another. Like you might be saying something and then be like, blah, 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 therefore, and you would summarize your thoughts. Or let's say you have a thought, but you want to contradict it. Like, I like hot weather, but not when it's windy. So it kind of, you use it to contradict. Same thing with however. I like hot weather, however, not when it's windy. In comparison is a transition word that will compare one thought to another. The word and also combines things together. Like I like hot weather and getting a tan. Or I like hot weather also getting a tan. Because you can use to explain things, and then is a transition word that will help you explain order, like what comes first, then next, then next. So these are all different types of transition words that you're going to try to use to explain later on what you learned how to do in this lesson. So first, in your own words, what do you think you're going to learn how to do in this lesson? All right, so we'll start with the vocabulary words. A lot of these you already know, so go ahead and tell me what is an inverse. Remember, the inverse is the opposite operation that we use to eliminate something with x. For example, adding and what are inverses? Adding and subtracting, get rid of each other. So does multiplying and dividing. So these are different inverses that we know. What does the word eliminate mean? Eliminate means to get rid of. So here, when we're saying we're eliminating something with x, we're getting rid of it. What does the word isolate mean? Isolate is the big word for to get alone. So if you have to isolate something, you have to get it all alone. And so when we're solving for x, another way to say it is that we're isolating x. So we use inverses to get rid of things, to eliminate things with x, so that we can isolate it and get it alone. Finally, the last word that we used here is operation. What does the word operation mean? Operations are things we can do in math, like add, subtract, multiply, divide, etc. It's ways we can combine numbers in math. That's what an operation is. So, so far we've done solving for x with one step. Now we're moving into two steps. And the important thing to remember, because you're going to be solving for x for all of your high school math, it shows up time and time again with different types of equations. And so I'm teaching you how to do it with one type, but you'll learn more. And the important thing to always remember is that when you're trying to isolate x, you must do backwards order of operations to solve. So in order to understand what I mean, I have to explain what order of operations are. If you learned PEMDAS for order of operations, the video and the extra videos before this lesson explains the difference between PEMDAS and GEMS, but they're basically the same thing. So I'm going to teach you GEMS. And so here's what the order of operations is. The order of operations is the order of the strongest operation to the weakest one. So when you do math, the strongest thing that you do is any grouping. Types of grouping are parentheses. There's also fractions. These you have to group the whole top together, then the whole bottom together first. There's root symbols. Roots kind of look something like this. Absolute values. Group things together. Absolute value looks like that. And brackets also group things together, which can look like this. Or like this. These are the major types of grouping, and they tell you to group everything inside of it into one number first before you do anything else. So if you have parentheses, everything inside the parentheses has to turn into one number. If you have fractions, the top needs to be one number and the bottom needs to be one number before you can move on. So once all your grouping's done, the next strongest thing you have to do is E is for exponents. So if you have any exponents up here, you have to take care of them first. The M stands for multiply. So that's the third strongest thing, is to multiply. But also to divide, because multiplying and dividing are basically the same thing. If you watch that video, I explain why they're the same. So when you have to decide what to do first, you always go from left to right. So you do what goes first from left to right. So if you see multiplying first, you do multiplying first. And if you see dividing first, you do dividing first, depending when you move left to right. So the S stands for subtract, but subtracting is just adding a negative. So again, adding and subtracting are the same strength, but you also just do whatever goes first when you go left to right when you read the equation. So these are the order of operations about when you have math and you're going forward. This one's the strongest, next. And adding and subtracting is the weakest one, which means if you're trying to solve for x, remember, in order to solve for x, to isolate x, when trying to isolate x, you must do backwards order of operations to solve. Which means if adding and subtracting is the weakest operation, you always get rid of that one first. Because it's like, instead of doing this one first, going forward, we're solving for x, so we go backwards and we do this one first. Then this one, then this one, then this one. So I have the Slay the Dragon example, where basically one way to think about it is X is the heart of the dragon. And you're trying to slay the dragon. Maybe there's a princess you're trying to save. I don't know. But you're trying to get rid of this dragon, and to kill it, you gotta get to the heart. But the dragon's protected, and it has all this stuff around it. So the heart has all this stuff protecting it. So in order to get to X all by itself, it is easiest to slay the dragon if you chop off the weakest parts first. So it's a lot easier to chop off maybe the tail or the hands before getting in closer to the heart, which is X. So adding and subtracting is the weakest. So you're going to want to get rid of that before you get rid of the things that's being multiplied or divided to X, or before any of that grouping or exponent. So that's one way to think about it. But it's important to note at this point that the two steps we're focusing on is you're going to have either a multiply and divide with an add/subtract. So first we learn this one, Then we learned this one. Now we're going to put these two together. So if you are multiplying and dividing or adding and subtracting, first you're going to get rid. So first you get rid of anything being added or subtracted to x. Then, once this one's gone, the next weakest is what's being multiplied or divided. Being multiplied / divided to x. I also have this marriage versus dating example, but I'm going to save it for a second for when we get to my 2 steps. So first, let's remember the 1-step examples. If -3 plus some number is going to equal 5, remember the equal sign kind of counts as a wall. And on this side of the wall, I have -3 plus x. And then on the right side, I have a 5. And my goal is to isolate x so that only x is on the left with nothing else. And then so I'll know what x will equal. Well, to do that, I have to get rid of this -3 that's getting added to x. So how am I going to eliminate this -3? Going to eliminate it by adding it over. Because it's a -3 that's getting added on, the opposite of -3 is +3. So I have to add it to both sides. Because remember, if I raise this side by 3 to keep them equal, I also have to raise this side by 3. So now -3 plus 3 is 0. They eliminate. And I'm just left with my x that I'm bringing down to right here. And 5 plus 3 is 8. So in this case, the answer is that x equals 8. So for this example, it says -3 divided by 2 times x equals 6. So this fraction is getting multiplied to x because there's no plus or minus sign in between them. So between the -3 and the 2, which one am I going to get rid of first? Remember, it's easier to get rid of the one on the bottom of the fraction. So we should get rid of the 2 on the bottom. And how do you get rid of that 2? Remember, if it's on the bottom of the fraction, it means it's getting divided by 2. And the inverse of division is multiplying. So I'm going to multiply both sides by 2. This 2 divided by 2 cancels and will just become the -3 from the top of the fraction and the x that's right there, equaling 6 times 2, which is 12. All right, how do I get rid of the -3 now? Because there is no plus or minus sign here, I do not add it over because it's not getting added or subtracted on. It is right next to the x, which means it's getting multiplied to that x. And the inverse of multiplying is what? The inverse of multiplying is division. So you have to divide both sides by -3 to end up with the fact that -3 divided by -3 is just the 1x, equaling 12 divided by -3 is -4. So that's how to do both types. Sometimes there's 2 steps. So in this example, there's 4 being multiplied to x, and then there's a -1, and it's supposed to equal 7. So whatever x is, first it'll get multiplied to 4, then you'll -1, and the answer will end up being 7. So to solve for x, I have to go backwards. Remember, the first thing you always get rid of is the thing being added or subtracted on. So this -1, how are you going to eliminate it? The inverse of subtracting is to add it, and I have to add it to both sides. And remember, I'm getting rid of this one first because in order of operations, adding and subtracting is the weakest. It's the last one you do. So when you solve for x, it's the first thing you get rid of. It's the first thing you eliminate. So now negative 1 plus 1 will eliminate, and I'm just left with my 4x's equaling the 7 plus 1, which is 8. Now, how do I get rid of this 4? Well, the inverse of multiplying is dividing. So I have to divide both sides by that 4. And then 4 divided by 4 is 1x. And 8 divided by 4 is 2. So x is going to equal 2. And if I took the equation, I could always check my answer because it's 4x minus 1. But the x I found was 2. So I'm going to put 2 here instead of the x. And then if I do the math, order of operations says I have to multiply first, and so that's 8, and then minus 1 becomes 7, which is, if you look at the original question, what they wanted it to equal. So we found the right x. We found what x needed to be. It has to be 2 in order to put it in there and make it equal 7. So another way to think about it, besides the whole get rid of the weakest thing first and then the next weakest thing to end up with the x by itself, is you can also think of the marriage versus dating example. When both things are happening, x is being multiplied to a number. And think of multiplied as the same thing as married. Remember, when two things are being multiplied together, like this fraction being multiplied to the x, right now that's called one term. It's like one term versus here, this negative 3 is one term and this x is one term. And they're separate terms because they're being separated by a plus and minus sign. But when things are getting multiplied together, it makes them one term. So when you are married, you are considered one. Same thing when you are multiplied, you're considered one. So if you're being multiplied in math, if you are multiplying things together, it is considered to be one term. Versus in real life, if x has an add-on, meaning you're adding or subtracting something on, it's like they are dating. They aren't one thing. When you're dating a person, you are two still separate things. You're just together hanging out on the same side. Like over here, they're hanging out on the same side of the equal sign. But they're not one thing. They're two different things that are just being added to each other. So, if you are trying to single up x, meaning you want x to be single, you don't want them with anyone anymore, it's way easier to get rid of your side hoe, the person you're dating on the side, than it is to get rid of the person you're being married to. So first, if we want x to be single, first we have to get rid of side piece, then the one x is married to. So you got get rid of the things that's getting added or subtracted on first, then the one that's getting multiplied to it. And so that's another way to think about it, to remember which one goes first. So if I come down to this example, x is being married multiplied to the negative 1/3. The add-on, the side hoe, is plus 2. So if I'm trying to single up x and get x all by itself, first I get rid of the thing that's being added on. So to undo the plus 2, I do what? Subtract 2. I have to subtract 2 to both sides. So So I still have the negative 1/3 x, but plus 2 minus 2 eliminates, becomes 0. Negative 10 minus 2 is negative 12. What's my next step? When it's just the fraction, now I can multiply the bottom away. So, because the inverse of divided by 3 is times 3. So the 3 divided by 3 is going to eliminate, and I just have negative 1x. And on this side, negative 12 times 3 is negative 36. Finally, how do I get rid of the negative 1? It's negative 1 multiplied to x, since there's nothing in between them. And the inverse of multiplying is dividing. So negative 1 divided by negative 1 will eliminate and just become the 1x, which is going to equal 36, because negative 36 divided by negative 1 is positive 36. On the left with x is a negative 2 and a plus 4. Which one should I get rid of first? Negative 2 is being multiplied versus this plus 4 is getting added on. So get rid of that one first by minusing it away to both sides. So I still have the negative 2x in front. Plus 4 minus 4 is 0. Negative 6 minus 4 is negative 10. And what's my next step? To get rid of the negative 2 that's being multiplied to the x, I divide both sides by that negative 2. Negative 2 divided by negative 2 will eliminate and become 1x, which will equal negative 10 divided by negative 2 is positive 5. And again, if I wanted to check my work, I could always take the equation, but instead of x, put a parentheses, and then inside the parentheses, put the x you found, this 5 that you found as an answer. And then if you do forward order of operations, you do negative 2 times 5 is negative 10, plus 4 ends up being negative 6, which is what they want it to equal. So I know I'm right. So this is how you would check your work. So I wrote here that this is how you end up checking your answer, is this whole process where you take the equation, plug in the x you found, and make sure it ends up being what it should equal by the end. All right, finally. In this example, what's my first step? The side piece is the minus 15. So to get rid of it, I add it away. And I have to do that to both sides. So that 3x over 2, because the negative 15 plus 15 cancels, because it becomes 0. And negative 9 plus 15 becomes 6. What's my next step? Next, I get rid of divided by 2 by multiplying both sides by 2. The 2 divided by 2 cancels, so I'm just left with 3x equaling 6 times 2 is 12. And what's my last step? 3x means 3 times x, and the inverse of multiplying is division. Because 3 divided by 3 cancels and becomes 1x. And it's going to equal 12 divided by 3, which is 4. And if I wanted to come over here and check my answer, so this C dot A stands for check answer. It's 3x, which happens to be 4 that we found, divided by 2 minus 15. Order of operations says G for grouping first, which means I have to turn my top into one number. To do that, 3 times 4 will become 12. And then I still have the divided by 2 minus 15. So G for grouping. Next is E for exponents. I don't have any exponents. Next is M for multiply/divide. Here's a division, so 12 divided by 2 is 6. And now I have 6 minus 15, and the last one is S for subtraction / adding, and 6 minus 15 is negative 9, which if you look at the original problem, they wanted it to equal negative 9. So I have the right answer. 4 was right because it does make it equal negative 9. So that's how you do it. So using the vocabulary words here, as well as transition words like but and however, and also explain what you learned how to do in this lesson.